Good morning, everyone. So I am Delphine Martin, Global Marketing Manager at Climalife. We are delighted that so many of you have joined us this morning to follow this webinar. So the target of this webinar is to present the issues and main changes linked to the new F-Gas III regulation on fluorinated greenhouse gases. The new F-Gas III regulation came into force on 11 March. Let's take a look at them together. We will be focusing on the quota allocated by the European Commission for HFCs, the total bans on the market for certain products and equipments, the new restriction for commercial and industrial refrigeration, air conditioning, heat pump for the new system and also existing equipment. We will also take a look at the solution available on the market to meet your expectations and those of your clients. To do this, I am joined by Mohamed Youbi Idrissi, Technical Manager at Honeywell. Good morning, Mohamed.
Good morning, Delphine. Good morning, everybody.
And Pierre-Emmanuel Danet, Technical Support Manager at Climalife. Good morning, Pierre-Emmanuel.
Good morning, Delphine. Good morning, everybody.
So let's start. First things, we'll talk about the key indicators, the GWP, Global Warming Potential. The new F-Gas III introduced a specific calculation to obtain the GWP of HFC-HFO blends. In concrete terms, the GWP of HFCs or HFC blends, such as 134A, 44A, or 410A, has not changed. It remains based on IPCC4 as before. However, for pure HFOs like 1234YF, 1234ZD, or 1233ZD, their GWP is now based on the 6th IPCC report. This means that the calculation of the GWP of HFC-HFO blends will take into account both IPCC. IPCC4 for HFC substances, IPCC6 for HFO substances. For example, for 48A, Solstice and 40, this refrigerant is a mixture of 5 substances. For each substance, reference will be made to the relevant IPCC report. What I mean, for R32, one of the mixture, it's an HFC, so we'll take into account the IPCC4, and for YF, it's an HFO, so it will be a IPCC6. So Climalife is working actually to update the F-Gas Solution mobile app. So very soon you will have a tool to help you to know the GWP of each refrigerant. Second point, very important in the new F-Gas regulation, is the quota allocated by EU. As you may have heard, the F-Gas III accelerates the HFC quota reduction with a total elimination by 2050. I'd like to remind you that the quota concern only HFCs or HFC blends. HFO are not included in the quota like reclaimed product. So this year, as you can see from the graph on this slide, we have seen a drop of more than 40% compared with 2023. Unfortunately, this will continue to accelerate with the new F-Gas regulation over the next 5 years. This sharp fall will have a major impact on the market. In 2025, a new decrease of more than 20% is expected, and in 2027, it will be more than 50%. So you can understand that today it's very important to take this change into account and to use more and more refrigerants with a very low GWP if we want to bridge this gap. It's clear that if the market does not switch to ultra-low GWP solution, the risk of the HFC shortage will be inevitable. Solutions exist to deal with this change and also to take account of the future bans. I will leave the floor to Pierre-Emmanuel, who will present you in details the new bans and restrictions and the solution to be in compliance with F-Gas III.
Thank you, Delphine. As you know, HFC are greenhouse gases that contribute to global warming, among many other sources of emissions. That is why they are covered by a regulation called F-Gas, which incorporates several constraints and rules. The F-Gas covers numerous chapters such as the containment of installation, leak checks, training, certification, and restrictions on use. Before going into detail, it is very important to note that from 2027, the Commission will issue evaluation reports to monitor the progress of the measures taken and to develop the F-Gas, which will have to be revised in 2040. These meetings will take place every 3 years and may modify or amend existing texts if necessary. The first point of this regulation is a timetable for reducing production by placing HFC under quota to limit the quantities placed on the market. HFOs, as Delphine said, are not subject to the quota. In the second stage, we will look at the bans by application and type of equipment. For quotas, this timetable shows that production rise will fall dramatically over the next 5 years. We will go from approximately 56 million tons of CO2 equivalent in 2024 to just over 9 million tons in 2030, reaching 4 million tons of CO2 equivalent in 2048. So over the next 5 years, we are going to lose 47 million tons of CO2 equivalent in quantity of new refrigerants. What does it mean? Well, the industry needs to manage its consumptions of new refrigerants to have sufficient quantities to maintain the refrigeration and air conditioning application. And to be able to do this, we obviously need to use a refrigerant with a very low GWP. This is the first challenge for the F-Gas. The second point of the F-Gas concerns bans. If you look at the top of the screen, we have since 1st January 2022 the obligation to no longer use refrigerants with GWP less than 150 in new centralized installations of more than 40 kilowatts, and only refrigerants with GWP less than 1500 in the primary circuit of a cascade system. This point existed in the previous F-Gas. We also see that tomorrow, on 1st of January 25, all refrigerants with a GWP over 2500 be forbidden for maintenance, excluding what you can read on the screen. On the same date, we have to use a refrigerant with a GWP less than 150 for all new self-contained refrigeration equipment, including that for commercial use. Then there is a new category, chiller, which from 1st of January 27 will use refrigerants with GWP below 150 if their capacity is less than or equal to 12 kilowatts, and an obligation to use refrigerant with a GWP of less than 750 for chillers with an output of more than 12 kilowatts. On 1st January 30, all stationary refrigeration equipment will be required to use refrigerants with a GWP of less than 150. And finally, on 1st of January 32, 2 points. We will not be able to use virgin refrigerant with a GWP greater than 750 for the maintenance of fixed refrigeration, exempt for exemptions again, and the use of HFC, including HFO, will no longer be accepted for chillers up to 12 kilowatts, except in the case of safety requirements. I remind you once again, from 2027, the Commission will study the evaluation reports every 3 years before reversing the F-Gas in 2040. So to conclude, solutions with GWP than less 150 are the standards to be achieved as quickly as possible. So now, what are the solutions? For refrigeration, let's take the example of supermarkets. To replace 404A or 134A, we use 448A and 513A for 10 years. 448A with a medium GWP must be managed in relation to availability, but stake is higher for new installations. The solution will differ slightly depending on the size of the shop. For stores of less than 2,000 square meters for medium temperature, we have 471A in centralized system with direct expansion or in chiller. We also have 1234ZE in chiller. And as you know, CO2 in direct expansion or propane in hermetical sealed system. And to finish, we have 445A in direct expansion in a semi-distributed condensing unit. What means semi-distributed? This is an independent multi-station unit, simply zoned. For example, we have condensing units that can be charged with up to 84 kg of 455A to supply the various cabinets of the stores. For low temperature, the solution are 445A, CO2 and propane. For stores over 2,000 square meters, we have solutions that cover low and medium temperature, such as CO2 boosters, 417A or 515B and CO2 in cascade system, and 455A in chiller. We also have for medium temperature 417A in a centralized system, 1234ZE in chiller with an HTF in a secondary loop, and for low temperature 445A in condensing units. Each refrigerant provides a technical solution, but it is important to choose one that is easy to use, the safety associated with the refrigerant category in terms of flammability and pressures, the cost of installation and energy efficiency. For convenience stores, next slide please. We find the same solution as in supermarket with in medium term the HFO, 1234YF for hermetic compressor. So you can see that we have 5 refrigerants with GWP of less than 150 to meet all your needs. The choice will depend on safety criteria, flammable or no flammable, and the cost of the installation. It's depending on whether we are using a refrigerant suitable for traditional installation with no technologies, or for super optimized installation but with a higher cost and a lack of technicians who know how to operate them. On this subject, Emerson estimates that CO2 installation will cost 30% more than a HFC or HFO solution for shops over 2,500 square meters, and 40% more for shops than less than 2,500 square meters, and 50% more for stores under 1,500 square meters. Of course, the environmental aspect must be also taken into account, because do not forget that F-gas aims to reduce global warming, so the choice of refrigerant should be based on the most energy efficient solutions to avoid the negative carbon impact in the long term.
Thank you, Pierre-Emmanuel. In the total agreement of what just been presented here, this table summarizes the potential solutions with a segmentation according to the surface of the store, from the very small ones, means food services and small independent store, to hypermarket having more than 2,000 square meters, but also for convenience stores and for supermarkets. As you can see here, we have 3 refrigerants having low GWP, less than 150, and ultra low GWP like ZE here, and they are able to propose a solution for all size of area. For example, R455A can be used in MT, medium temperature, but also in low temperature, regardless the store size. R471A and 1234ZE both can be used for medium temperature, in condensing unit, in centralized system or semi-centralized system, but also in direct expansion and in chiller with a water loop system, for example. Now, sorry. Now, let's have a look on some example of a realization. The first one here is an example of a project carried out for an express format for convenience store. Here, this is a remodeling dating from 2022 with a sales area of 800 square meter. And the choice was made to use R455A in both LT and MT condensing unit for cold chamber. As you can see, the store manager testimonial in which he explained that he was very happy on this solution because this refrigerant provide him safety, but also saving on energy and cost. Now, let's have a look at what's happened exactly. Here we have the result of an eco-efficiency calculation for this convenience store compared the baseline solution on 455A to another solution based on the use of CO2 as booster. The simulation was done for 10 years shelf life of the machine, including all elements of cost, means CapEx, OpEx, and also the total emissions in terms of the CO2, direct and indirect emissions. First, we can see that R455A offer 10 kilo euro reduction cost in addition of 60 euro others during 10 years. The first 10 euro coming from the reduction in CapEx and the 60 euro additional coming from operation, coming from OpEx, especially with the reduction of energy consumption because of the optimum consumption of 455E solution. Now, in terms of CO2 emission, as you can see in the last column, the 455A produce approximately 22 ton equivalent CO2, including direct emission coming from leakage and indirect emission, coming from energy consumption, compared to 25 for the CO2 solution for the same perimeter. Another example, and this one is for a large store. This is a hypermarket, very recent, opened the doors last February in France, in Corsica, having roughly 4,200 square meter. And here also, the solution based on 455A was selected for different reasons: for safety, for cost, for simplicity in terms of the maintenance, and for energy efficiency. Technically speaking, 3 centralized units have been installed here. 2 centralized for empty needs, approximately 300 kilowatt. It was a chiller producing cold water at -8, -4 degrees C, and distributed cooling to display cabinet and medium temperature cold rooms. The third machine was in direct expansion, having roughly 60 kilowatt cooling capacity for LT display cabinet and cold rooms. In this example, please note that the total charge of refrigerant in this hypermarket is around 431 kg only, I would say, and this is a very low because of the water loop using for the empty systems. A third example with the use of 455A for an independent small stores, Crocandis, which equipped its freezing chamber of about 12 cubic meter with a condensing unit working with 455A. And again here, as you can see, the manager of this store is very happy with this solution because it provides them low GWP, better energy efficiency, less risk than using hydrocarbons, as well as sustainability. And to finish this series of example, here we have 3 cases study of OEM choosing R458A for their equipment using in professional kitchens and restaurants, such Turner's equipment, the ladder for kitchen equipment, professional kitchen equipment, the Gunson or Hengel, which manufacture a rapid cooling cells. For all this example, the motivation to switch to this refrigerant was the maximum safety and performance with lowest cost of ownership.
Okay, that's all what we can say about the commercial refrigeration sector. Now let's look at industrial refrigeration. Once again, for retrofit, we find 513A and 448A. Let's not forget that we also have reclaimed refrigerants for maintaining existing installation in service, which is a solution to avoid consuming quota. In new installation, we will see that for medium temp, in chillers, in fluid installations, or in DX systems, it is extremely simple. We have HFO 1234ZE, which is a refrigerant that all technologies agree on. It is also classified in group 2 of the PED, the same category as 134A. And in the low temperature, we have propane, ammonia, CO2, and 445A direct expansion system. What is the scope for cold storage? We find for medium temp the 1234ZE again, and also 471A, and for low temp 445A, and 1234ZE with CO2 in cascade system. So we always find the same refrigerant in all the system and for all solutions.
Thank you, Pierre-Emmanuel. So here also I present you 3 different examples of application in industrial refrigeration. The first example, it was what you have in the screen. Here we are in the chocolate industry with Maison Picot, adopting ZD as a refrigerant for its refrigeration need. In this example, the beauty of this project is double. First, the use of Greenway as a bio-source coolant in water loop, add to ZD as ultra-low refrigerant, which is very interesting from the footprint impact on this project. And the second interest is the recovering of all heat, allowing to optimize the energy of consumption and use it in their process. The second case study, here we have a logistics platform in the south of Europe, choosing also R455A for medium temperature. In this example, in fact, the space classification and the system location are not subject to load restrictions and allowing, consequently, to have an installation in direct expansion using about 800 kg of the charge. Again, here, the motivation of the end user was both low installation cost and the maintenance cost also compared to the ammonia. The third example, here we have an empty warehouse to maintain the temperature between 4 and 8 degrees C, and to provide the cooling for the condensing unit using CO2 for low temperature. To meet these needs, three chillers with 455A have been installed. And as Mr. Gilles Caron reminds us, this family of fluids makes it possible to process power ranging from 100 kilowatt to 200 kilowatt cooling capacity offshore easily and without affordable technologies.
Thank you, Mohamed. As we have seen, many solutions exist today for stationary refrigeration to be in compliance with the new regulation. Let's have a look now at the restriction bans to come for air conditioning and heat pump.
Yes, Delphine. What is new with the air conditioning and fixed heat pump sectors? From January 1st, 2026, it will be forbidden to use virgin refrigerants with a GWP more than 2,500 for the maintenance of installations. From January 1st, 2027, we must use a refrigerant with a GWP less than 150 for plug-in units, self-contained, air conditioners, or heat pump of less than 12 kilowatt. And for packaged air conditioners or for a self-contained equipment and heat pumps up to 50 kilowatt, we have the same obligation. 1 January 1st, 2030, GWP of less than 150 will be mandatory for all standalone equipment and heat pumps except for safety requirements. These safety requirements have to be yet defined. Finally, on January 1st, 2032, all HFCs and HFOs will be banned for packaged units, standalone heat pumps, and heat pumps of less than 12 kilowatt. In the air conditioning segment with splits and chillers, on January 1st, 2025, refrigerants with a GWP of more than 750 are banned for single split with a charge of less than 3 kg. This is still a ban on the use of virgin refrigerants with a GWP more than 2,500 for the maintenance of air conditioning installation, but this will apply from January 1st, 2026. From January 1st, 2027, it will be mandatory to use refrigerant with a GWP less than 150 for all split and for chillers up to 12 kilowatt. And refrigerants with a GWP of less than 750 for chillers of more than 12 kilowatt. And always except for safety requirements. The next stage will take place on January 1st, 2029, when all air-to-air splits will be required to use refrigerant with a GWP of less than 150, and splits of more than 12 kilowatt will be required to use refrigerant with a GWP of less than 750, but still exempt if there are safety requirements. In January 2032, all HFCs and HFOs will be banned for chillers up to 12 kilowatt. Moving on, we arrive at January 1st, 2033. Refrigerants with a GWP of less than 150 will become mandatory for all splits over 12 kilowatt unless there are safety requirements. And finally, on January 1st, 2035, all HFCs and HFOs will be banned for splits of up to 12 kilowatt. After January 1st, 2032, reclaimed refrigerant will continue to be used for servicing and maintenance if GWP is less than 2,500. What are the solutions for air conditioning and heat pumps? It is clearly simple. In chillers, we had 134A in centrifugal screw or small centrifugal compressor. In low pressure application, we have 1233ZD. And in the other application, we have 1234ZE, two pure HFO with very low GWP. In scroll application, to replace 410A, the solutions in transition in case of the system is outside is 455B, and for long term, we have again 1234ZE. If we have the system inside, we have 515B. The interest of 515B is the low GWP, 288, interesting to preserve quota, and it's a non-flammable product, A1 classification, so easy to use in all cases, with same capacity of 1234 ZE. So now let's see the rest of solution in this category. In rooftop, air system, air-water heat pump, and multi-split, we have 410A. In majority of this system, we had scroll compressor. For transition, we have two solutions, 454B or 32. For the long-term solution, it is also simple. We have 455A and 454C. So once again, solutions at less than 150 GWP are available to respond of all the necessity of a product.
Yes, thank you, Pierre-Emmanuel. Yes, solution for this segment of market again exist, and let's see some example of realization. The first one, it is an amazing example of the Eiffel Tower. Yes, Eiffel Tower switched to 1234Z ZE 2 years ago. In fact, the west pillar of the Eiffel Tower needed to renew its chiller water production equipment, having roughly 120 kilowatt. It was old Tran chiller, and it was time to renew this installation. And after reflection, the solution carried out here was to use 3 small unit of 40 kilowatt each one by using R1234ZE as ultra low GWP solution. As a result, as you see here, the solution was very simple, efficient, and sustainable. A second example for another industry. So here we have the company cut, showing the use of R515B in replacement of another refrigerant used before, which is R227EA. Here, this is an industrial air conditioning, and you see the condition in terms of the temperature, especially for the condensing temperature. We have at very high temperature. The condensing temperature here is about 80 degrees C. And in this table, we compare all the conditions of the old system based on R227EA and the new one. All the conditions are very, very similar, especially for the evaporating temperature, for the condensing temperature, for the superheat, for the liquid temperature, and for the cooling capacity, means the same needs for both cases. But the difference here, it's in terms of energy consumption. As you can see, for the first case, we consume 8.5 kilowatt, and for the second solution based on the use of 515B, low GWP, the energy consumption, it's only 5.5 kilowatt. That means we have here 30 to 40% energy saving, which is a very, very interesting solution. The last example, so we are here in the hospital. It was a hospital in the south of Europe, in Malta especially. This is a public hospital, opened in 2007, having more than 250,000 square meter, 825 beds, and 25 operation rooms. So the existing HVAC infrastructure was old, and the reflection was to renew this HVAC installation by a new one. And the solution selected here was to use ZE in integrated heat pumps. Means that we are able here to produce a domestic hot water supply, dehumidification needs, and the heating of all this space. As a result of this technical solution based on ultra-low GWP 1234ZD was one, reduction of diesel fuel consumption by 1 million per year, meaning that we save more than 2,700 million tons CO2 equivalent, or on other words, 58% saving in fossil fuel related use, the energy used by using a boiler, for example. In the top of that, we improve also the indoor and outdoor air quality for this use.
Thank you, Mohamed. So we already have many molecules available and validated by the market, so we can all comply with the regulation. And advice, do not wait. Let's see now what will happen to the maintenance of existing equipment. What do we need to do the check leaks? And what about the certification and training of people?
Okay, now let's take a closer look at the dates for the use of new refrigerants known as virgin and reclaimed or recycled refrigerants by activity. For the maintenance of refrigeration installations, virgin refrigerants with a GWP higher than 2500 will be banned from January 1st, 2025, except for what you can see on the screen. Then, from January 1st, 2032, the GWP will be reduced to 750 for maintenance. Reclaimed and recycled refrigerants will be banned from January 1st, 2030, while all reclaimed and recycled refrigerant with a GWP of less than 2500 will remain accepted. For the maintenance of air conditioning systems and heat pumps, virgin refrigerants with a GWP of more than 2500 will be banned from January 1st, 2026. Reclaimed or recycled refrigerant will be banned from January 1st, 2032 if they have a GWP of more than 2500. And as for refrigeration, reclaimed and recycled refrigerant with a GWP of less than 2500 will continue to be accepted for air conditioning and heat pumps. What is about leak detection? The F-Gas 2024 regulation covers two families of refrigerants, the family of HFCs and HFC-HFO blends, and the family of pure HFOs. For the HFC family, we find exactly what we had in the F-Gas 2014. Leak checks must be done depending on the charge of the installation in tons of CO2 equivalent. Between 50 to 50 tons of CO2 equivalent, you have to control the leaks every 12 to every 24 months if you have a fixed leak detection system installed. Between 50 to 500 tons of CO2 equivalent, the frequency is every 6 to every 12 months if fixed leak detector is installed. And when you have 500 tons of CO2 equivalent or more, the frequency is every 3 or 6 months. You have some exemptions and you have a new date for a new section which you can read directly on the screen. A new rule appears. The new F-Gas introduced the leak testing for HFOs based on the same principle, but the charge is in net kg of refrigerants. So we have a frequency of leak checks according to the net white charge in the system. This is as follows for the charge between 1 to 10 kg leak control every 12 months or every 24 months if you have an indirect leak detection system. Between 10 kg to 100 kg frequencies from 6 months to 12 months with leak detection systems. At 100 kg or more, it is every 3 months or 6 months. Good to know. The indirect leak detection system must be checked at least once every 12 months to ensure that they are working properly. And to finish, the last important point, in the event of leak in a system, you have to repair and to check that the leak has been eliminated. But you should also carry out a leak test between 24 hours and 30 days after the repair. What is about the certification? For the legal entity, it is the company, nothing changed. We regard the regulation 2014, certificates remain valid. For the technicians, there is an important change. The certification is no longer valid for life. Certificates meeting the requirements of previous F-gas remain valid, but by March 2029, at the latest, individual holding certificates according to F-gas 2014, as well as those who do not have them, must attend upgrading courses or undergo an evaluation at least every 7 years. To do this, training on all HFC, HFO, HC, ammonia, and CO2 refrigerants becomes mandatory and is included in the training program. The European Commission will establish the requirements for certification and training programs before the 12th of March 2026. Member states shall ensure the certified natural persons are required to attend refresher courses and undergo evaluation at least every 7 years.
Thanks a lot, Pierre-Emmanuel and Mohamed. It's clear that we did a panorama about, we summarize all the changes and many issues with the new F-gas regulation. You understand that it's key to anticipate future restriction bans now and to be aware of the drastic reduction in HFCs over the coming years. Several technologies exist to meet your needs. HFO and HFO blends are authorized without limit until at least 2050, except for domestic refrigeration in 2026 and chiller less than 12 kilowatt in 2032. We will have also an exception for plug-in, monoblock, self-contained or split system less than 12 kilowatt for air conditioning and heat pump application. So, if we want to maintain existing equipment, the recovery of refrigerant is key. The reclaimed product will be more and more important for the future. But above all, it's important to choose the refrigerant that will offer the best energy efficiency for the end user. As you know, energy is the main issue for the years to come. The second is, of course, the personal safety. So different products exist that are simple and effective to implement. So don't wait any longer to act if you want to be confident and offer a long-term solution to your client. Thanks a lot for your attention. So we are on time. So let's go now to the session of the question. So we will see the first one concerning the PFAS. The question is, concern around PFAS in lower GWP HFC HFO blends is impacting on the continued use of higher GWP refrigerant where CO2 and hydrocarbon options are not considered viable.
Yeah. I can answer this question. Thanks, Delphine. This is a very relevant question, of course. I can give an answer in 2 minutes or 2 hours. I think regarding the time, I will be shorter. To answer this question, just let's remember that the PFAS or the polyfluoroalkyl substance are a large group of chemicals substance, more than 100,000 substance. They are present everywhere. They are present in electronics, in semiconductors, in energy, in construction product, in industrial process, coating, lubricants, petroleum and mining, medical devices, a lot of applications, so and so. And yes, our refrigerant theoretically are a PFAS also, only because of its chemical structure. And now we speak about the PFAS because, as you know, in the last March 2023, the European Chemicals Agency, ECHA, published a proposal submitted by Germany on behalf of 5 countries, including Sweden, Denmark, Netherlands, and Norway. But in this proposal, and this is very interesting, in this proposal, there is a general assumption that all PFAS are persistent and that they pose an unacceptable risk. Long story shorter, in reality, and according to many scientific papers and studies, yes, some bad PFAS are indeed persistent, especially the liquid and solid ones, like the polymers, for example. However, synthetic refrigerants like HFC, HFO are not PBT, nor persistent, nor bioaccumulative, and no toxics. And in my opinion, they should be outside any future restriction, and this just fact and science. So if you know, we are relaxed for this question, and we will see what happened in future years.
Thank you, Mohamed. Another question concerning HFOs, about the availability of HFOs, especially 1234ZE, on the European market in the future. Who would like to answer?
Yes, I can take it. The availability of HFO is ensured by reinforcing production with new plants. That lack of availability due to climatic events has been resolved, so normally we do not have any problem with this availability of a product in the future.
Okay, thank you, Pierre-Emmanuel. Another one concerning the propane. So R290 becomes a standard refrigerant in European heat pumps. Will there be long-term alternatives for these refrigerants?
Yeah, I can take this question. In fact, confirm that the propane is a standard solution for heat pump. I don't agree totally with that. That depends on the type of heat pumps. It can be true for water-to-water heat pumps, maybe water-to-air heat pump, but absolutely not for air-to-air heat pumps. As alternative of propane, and it is we have many case studies in the market. We have the 455A as solution, low GWP, less than 150, but also 454C also as a solution. Both this refrigerant can be used for heat pump and for all type of heat pump, water to water, air to water, or air to air.
Thank you, Mohamed. So we receive another one. It's concerning more the calculation of the GWP values. So can all heat pumps continue to be calculated with then current global warming potential value based on the 5th assessment report of IPCC, or do they have to be recalculated with the current GWP values?
Okay, I take it. F-gas based GWP values on IPCC report 4 for HFCs and report 6 for HFOs. HFC and HFO blends are calculated on this basis, as you explained, Delphine, at the start of the webinar. We have a special GWP based value with the F-gas regulation, so we have to do with. And to find all these GWP values, we will propose the Climalife F-gas solution application. You speak about it on the start of the webinar also, Delphine, so I think that everybody can find all these GWP values in this application.
Thank you, Pierre-Emmanuel. So we receive also other question. It will be managed later by our expert. And don't worry, we will put online all the question and answer in our website. So thanks a lot for your attention. You will receive next week the link of the replay, and it will be available in our website. If you want to receive the presentation, feel free to contact our Climalife sales team. I wish you a very nice day, and bye-bye.
Bye-bye.
Goodbye, everybody.